Good morning to all. Today we are going to discuss Unit 2 Spatial Data Model. The topic is ER diagram. So the ER diagram is nothing but entity relational diagram. How the each and every nodes are joined. The things we are going to discuss. So the outcome of this topic is develop data model using GIS. The program outcome of this course topic is 1, 3, 5, 6 and then 9. And program specific outcome 1. The outcome of this topic is develop data models using GIS. So the entity relationship diagram. So see, this is the entity, this is the relationship, and final one is the attributes. So the rectangular represent entity sets, diamonds represent relationship set, lines links attributes to entity sets and entity sets to relationship sets. So the ellipse represented attributes, double ellipse represent multi-valued attributes. Then dashed ellipse denote derived attributes, underline indicate primary key attributes. So the entity relationship diagram. So see from the student ID, name, address, phone number, manager, advisor, credit, GPA through the enroll in course. So like course name, credit number, time, room, instructors. So the entity relationship model, the result is a diagram of all the entities, their attributes and the relationship between entities. Each entity become a table, student table, course table. Each relationship usually become a tables enroll which allows you to join information from both tables. So types of relationship between entities. One faculty member is assigned to one office. One faculty member teach many courses. Many students take many courses. All of this relationship can exist between attributes table. So this is the table join. So first on the trails table from relationship joins. So table joins. Table join depends on the data, not the attributes name. There are many different types of tables joined. Tables can be joined regardless of the relationship expect. So when joining to the features attributes table in a GIS, the relationship must be 1:1 or m:1. Other relationship must use the relate. So 1-to-1 join. So employee ID job, then employee ID from John name, the joined employee ID to employee ID. So after join, this will be refactored like table 3. So a join does not permanently alter the table structures. So many to one join. So see from polygon ID, here symbol, here's the description. So it will be added many to one. Then relate in a GIS. So it will be related to attribute of stand. The relational algebra. Code's specification of a relational database relies on relational algebra. Relational algebra takes tables relations as input and return tables as output. The algebra combines or split tables by rows or by columns to generate either a subset of tables or an expanded tables. The fundamental building blocks. Tables comprise the fundamental building blocks of any database. So the table above contain the employee information for an organization characteristic like name, date of birth and titles. Relational algebra. 5 basic operations: select, project, union, difference, Cartesian product. So the operators take one or two relation as inputs and produce a new relation as a result. Relational algebra, derived relational operates. So intersection, divide like not used very often, then joint. So this can be expressed using different combination of the fundamental operators. So select operation example. So relation R, then select from relation R where A is equal to B and D greater than 5. So database queries. So queries may be made of one table or several tables at the same time. In many systems, querying is facilitated by icons or menus or queries by examples. QBE, a graphical query language. The structural query language, DDL, data definition language, used to create and manage the database. DDM, data manipulation language, used to query the database. So the SQL, widely used non-procedural language. So example, find the name of the customer with the customer ID. Select customer name from customer, where customer ID is equal to. When application programs generally access database through one of language extensions to allow embedded SQL application program interface, example ODBC or JDBC, which allow SQL queries to be sent to a database. The attributes queries, simple selection and selection. So record with area is greater than 20, so it will be formulated like a table. The record with the land use is equal to urban and municipal is equal to city, so it will be separated. So the queries based it will be formatted. Or our comments also we can use, or not comments also we can use. So and or and not. So the ArcGIS attributes queries interface, so state the tables is open. So likewise select attributes, then we can create a new selection. The new selection we can apply, then we can set whether it is R and or maybe not. So table is open. Now option related table selected by attributes, switch selection, clear selection, zoom to selected, deleted, and then selected. So no table is open. So selection select by attributes from the menu bars. So a spatial query in SQL, select city dot name comma city dot geometry from city comma country, where country dot name is equal to Pinochet and city dot geometry inside country dot geometry. So city dot population greater than 30,000. So spatial selection. So select by location. So the location based we can identify. Okay. So spatial selection methods. And assessment part of the session. Draw the use case diagram anyone application oriented. So these are the reference material. Thank you.